All right, lesson 3, inequalities in one triangle. The objective for the lesson, students will be able to recognize and apply properties of inequalities to the measure of the angles of a triangle and the relationship between the angles and the sides of a triangle. When it gets down to definition of inequality, don't worry about that one right now. I will talk about it later on towards the end of the lesson, but for right now, it really doesn't make too much of a difference. So I'm going to ignore it for now, and I'm going to get to talking about the theorems, specifically that angle-side relationships that they have in triangles. All right, so with the angle-side relationships in triangles, as you can see, if there is a small angle in the triangle, it's going to relate to the smallest side of the triangle. The biggest side on a triangle is going to relate to the biggest angle. So yeah, biggest side is going to show you the biggest angle. All right, and then the smallest angle or smallest side is going to correspond to the smallest angle as well. Okay, and then the middle side will be the middle angle. Again, nothing too crazy, just that's really what those theorems are saying. Okay, the biggest angle goes to the biggest side, the smallest angle goes to the smallest side, and in reverse, if you have the smallest side, that goes to the smallest angle, biggest side, that goes to the biggest angle. All right, I'm going to go into some of these examples with you. All right, we're just looking at this very first triangle. It says to list the angles and the sides of the triangle in order from the smallest to the biggest. And that's what that said. I just wanted to zoom in so that way you could see it just a little bit better. Oop. All right, so we've got the triangle here. It does show you all three sides of that triangle. You got the 11.1, the 14.3, and then the 12.5. All right, I'm going to circle the very first one. This 11.1 is the smallest, so I put a little number 1 next to it. 14.3 is the second smallest, and then that 15.7 is going to be the biggest one. That's the largest side that we have. So because of that, I kind of wrote the numbers 1, 2, and 3 just to show that 11.1 is the smallest, 2 is the next smallest, and then 3 is going to be the largest of all of them. So I'm just going to go ahead and write those sides in order. So the smallest side is going to be AB. You can see they have the two vertexes of A and B. I'm going to put the A and B with a little line over the top of it. On for the middle size, that's going to be side BC. All right, with that BC, I'm going to make sure to write those with a line on top to show it is a line. And then the biggest side is going to be side AC. All right, so AB is the smallest, BC is the middle one, and then AC is going to be the largest one. Because we could figure out the sides, we're also going to go ahead and be able to figure out the angles that go along with it, okay? So I got the highlighter out to show AB is going to be that smallest side. If you look all the way across that triangle, angle C is going to be the angle that matches up with that side. Okay? So when I start looking at the angles themselves, I'm going to write down angle C is going to be the smallest angle. All right? That's kind of where I wrote that little 1 down there just to show that that one matches up with the side, kind of that the smallest side matches with the smallest angle. All right, on to the next side. I'm going to get a highlighter here. That middle one, kind of that Goldilocks one, not too big, not too small, in the middle, just right. That's going to be that side BC. BC is that middle one. And if we look straight across that triangle, and I kind of make a little mark to show straight across that triangle, I see that angle A is completely opposite from side BC. So I'm going to put down angle A, and that is going to show that angle A is going to be the middle size for that triangle. And then the very last one Getting that highlighter out again. I'm going to highlight AC. That's going to be the biggest side that we have, the largest one. And then the angle that is opposite to side AC is going to be that angle B, kind of where I put the end of that highlighter at. So the largest angle that we have is going to be angle B. All right? So one thing I want to show though is that with this, I've got the letter A, the letter B, okay, both of those are my first two letters. I need to have all three letters involved. So AB is going to be the side. The only letter that I have missing out is going to be that letter C. So I've got an A, I've got a B, I've got the letter C. I've got all 3 points of the triangle to show that I didn't copy anything over, I didn't accidentally choose one of the wrong angles or one of the wrong points for a side. So again, I'm just looking at all those letters to make sure I don't repeat them. I only have one A, I only have one B, and I only have one angle C. All right, on to the kind of the second example. I've got the letter B, I've got the letter C, and then for my angle I have letter A. You can see I do not repeat any of those letters. I only have one A, I only have one B, I only have one C. Because of that, it's kind of a quick, easy check to verify that I did it right. I didn't repeat anything, so I'm good. And then my largest side, I've got that angle vertex A and C. So I've got A and C for my line segment, and then the only other letter that I don't have yet is the letter B, and I do have that on the angle. So I just want to show that you can use, looking at all 3 of those letters, make sure you don't repeat any of them on a triangle. As long as you don't repeat any of those angles or those letters, for the most part, you have probably done it right, as long as you're writing down what the kind of that largest to smallest order is. All right, on to example number 2. All right, I'm going to look at these sides. I've got 3.7, I've got 4.8, and I've got a 7 for the sides of my triangle. Still, smallest to largest is what the goal is. So 3.7 is going to be our smallest. Okay, and now I'm going to look for the middle side. That's going to be that 4.8. That's the middle. And then the largest side of the triangle we have is going to be that number 7. That's the biggest number. I'm just looking at numbers from the smallest to the biggest. All right, so as I go through and try to figure out how I'm going to set this up, I'm going to make myself a nice little chart on the side. I'm going to put side there. I'm going to make a little T chart there, and I'm going to write the angle for the other side, just to show that the sides and the angles are all going to match up. So the smallest one was side AC. That's where I put the number 1. And then also I'm going to have that angle B. Angle B is going to be the angle that matches with that. Now I'm going to look at the second angle where I put the little star. That's going to be side AB. I've got both those letters. And now I'm going to look at the angle that is completely opposite of side AB. Go all the way across, and I'm going to see that that is angle C. All right, I can verify I didn't screw up. I don't repeat any letters. I've got an A, I've got a B, I've got a C. No letters are getting repeated, so I did it right. Finally, the biggest angle I have, it's that one. So that's going to be the third side. That's side BC. It is my largest side. I'm going to match it up with the angle of angle A. So side BC is the largest. Angle A is also going to be the largest angle because, again, those sides and those angles all kind of match up as long as you go with opposites. I'm doing a quick little look once over. My first one has an A, a C, and a B. The next one has a B, a C. You get the idea. All right, for number 3, this sample, instead of having all of the sides, we're giving the angles. Okay, I already have the number in for this triangle. I've got a 51, I've got a 39, and I've got one angle that's going to have that little square on it. Okay, that means it's a right angle, and a right angle is 90 degrees. Okay, if I was still trying to figure out what that missing angle was, what I'm going to do is I'm going to figure out how many degrees are in a full triangle. So a full triangle has 180. So in order for me to figure out what that missing angle would have been, I'm going to be able to subtract all those numbers from 180 to figure out what that missing number was. So I've got 180 minus the 90, because that's my right angle. I'm left with 90 degrees. And then I had 90 degrees minus the 51. That leaves me with 39, and that's where that 39 came from. Okay? So now they understand where all those numbers came from. Now I get to look at those angles. Excuse me. I get to figure out which angles are going to match up with the sides on my triangle. Just like before, we're going to have the sides. I'm going to make a little chart. I've got the sides, I've got the angles, and I want to make them from smallest to largest. So looking at this chart, the smallest angle I have, the smallest number is 39. I need to look at the line segment that is completely across from there. So perfectly across from the 39, where I have angle X, because that's my smallest angle, it's going to be the other two letters. So I've got the line segment of W and Y. So I've got line segment WY because that's opposite of where that X is at. Okay, I'm going to draw along the outsides, those vectors on the outside of the triangle, and they're going to point directly to those points, and that's how I got line segment WY. So that's the smallest line segment along with the smallest angle of angle X. All right, now I'm going to look at my second size. So I did the smallest one. I want to go for the middle one, the medium one, the Goldilocks one, if you will. All right, not too big, not too small, just right. All right, so we're going to go with 51. 51 is the middle one. Okay, you can see that angle W is where 51 is at. And now I'm going to go with the line segments that are completely opposite of that. So it's on the opposite side, that's that X and the Y. And I'm going to write both those letters with a line over it to show that it is a line segment. And side XY is my middle one. Finally, I'm going to go with my very largest angle. My largest angle is going to be that right angle, that 90 degrees. So I'm going to write down angle Y is the largest angle. And then the line segment that is going to be part of that angle Y. Follow those vectors from the edge. And I'm going to have line segment WX. Okay, I'm going to look through. I've got WX, the very top one, I've got a WY and then the angle X. Nothing repeats, so I'm good. The middle one, I've got an X, a Y, and a W. None of those letters repeat. I'm good. Finally, WX and the Y, nothing repeats. And just verify I went from the smallest to the biggest, and I am set when looking at that one. All right, we're going to go on to sample number 4. Number 4, I want you to do all on your own. Okay, what I'm going to do is I'm going to give you some time to work on it. Pretend like I didn't write or circle that 45. I want you to figure out the smallest, and then I want you to go to the largest for both the angles and the sides. I'm going to give you 1 minute to work on your own. Go ahead. All right, time is up. All right, let's see how you did. All right, looking at the sides, or the angles, trying to figure out the sides. Angle B is my smallest angle because of that. Side AC is going to be my smallest side. My next one is going to be, or the smallest angle is going to be angle C. That's my middle one. And then the side opposite of that is going to be line segment AB. And my largest angle is going to be angle A. And my line segment for that one is going to be line segment BC. Hopefully you got that one down. Yeah, I know you did. Great job, everybody. All right, this next part, this is where I said I'm going to get to it a little bit later on. The exterior angle inequality theorem. Really what this says, and I'm going to kind of explain stuff that we did last chapter from when we were trying to figure out exterior angles when you had the interior angles. All right, remember if you had that exterior angle like angle 4, that is going to equal angles 1 and 2. So we have that exterior angle. It's going to equal to angle 1 and 2 if we add them together. Okay, no matter what, angle 1 plus 2 is going to add up and it's going to equal angle 4. All right, what we're going through with this theorem, what it's saying, is that because those two angles have to add together to equal angle 4, there's no possible way that angle 1 could ever be bigger than angle 4. Angle 2 could never be bigger than angle 4. So they, no matter what, have to be smaller than that exterior angle. That's what this exterior angle theorem is actually saying. It's just saying that the exterior angle is going to get added up by those other two interior angles, the ones that are opposite from where that point is at, and they're not going to touch each other. So that's where we're going with on this part of the problem. Okay, so in this first example where it says name two angles that have measures less than 74, my exterior angle, I'm going to get a highlighter here, exterior angle is going to equal 74. Okay, 74 is what angles 1 and 3 are going to add up together to equal. So remember, if I do angle 1 plus that angle 3 added together, they're going to equal 74 degrees. Because of that, when it says two angles that are less than 74, I'm going to be able to write down that the vertex, I'm going to write those points, angle V and angle W are both going to be less than 74 because those two angles have to add up to equal 74. All right, same thing on number 2, the same sample problem. It says name two angles that have the measures less than 82. 82 is my exterior angle, so I need to find the two angles that do not touch that vertex, do not touch that point at all. Okay, the ones that don't touch angle E are going to be angles 3 and 2. So again, the two angles that are less than 82 are going to be those vertexes of angle C and then also angle D. Both of those are going to be less than 82. Again, nothing too crazy, but that's really what it was. All right, time for you to work on your homework. Assignment is page 348, numbers 5 through 6, and numbers 14 through 19, and then finally the number 22. Go ahead and work on that. Turn it in if you get done with it. On Monday, we're going to do some logic problems, and then we're also going to review for the quiz kind of during that second half of the class. We will have a quiz on Wednesday over sections 5.1 through 5.3. Reminder, you do have that 5.1 through 5.2 special segments and points of a triangle piece of paper that I gave you yesterday. I gave you on Thursday. You can use that on your test and your quiz. Go ahead and fill that out. Make the best notes you can on that one. That's kind of a free gimme sheet. And then also you can use a note card for your quiz and your test, just like every other time. That's all I got for you. All right, have a fantastic rest of the class.